Hello and welcome back to Calculus 2 section 10.8 on choosing the test. We learned 10 tests, and those 10 tests have rules, right? And you can, in some cases, use multiple tests to solve a problem. But mostly, you get to pick one test that works. So now, in this section, I would like to talk about the correct way of choosing the test. So the way I go about these things is, anytime I see a series, I immediately try divergence test first. It's fast, and if it works, which is one step only, if it works, problem is divergent and I'm done, right? Now, if you get limit is equal to 0 by divergence test, then you have to pick and choose and go through thinking and so on. So I'm going to start with number one. Say try divergence test. That was in 10.4, and that one said if limit n goes to infinity of an is different than 0, then we have divergence, and you are done, right? So that's the test. You take the limit of the sequence, right? Sequence is the an within the series. Series is the sum of the sequence. So you take the limit of an, and if that one is anything but 0, could be 1, could be e, could be infinity, right? Anything different than 0, it's divergent, and you are done. Otherwise, well, let's do this. If limit an is equal to 0, we have to pick different test. So all of your problems on exam, all of your problems, the final, all of your problems in power series, all of your problems, right? You should always start with the divergence. You always say, can I just knock this problem out of the exam immediately? And it's so quick, you just take one limit. So if you get that the limit is 0, then you have other question to ask yourself, right? So I'm just going to put a bunch of these arrows like this, and they lead to different. You can ask yourself, do I have -1 to the n, right? You ask yourself that question. If the question is yes, right, then use alternating series. That was 10 point something, 10.6? Yeah, 10.6. So that could be one possibility, right? You can say, do I have summation AR to the n, right? Because then it's geometric. Do I have an plus 1 minus an, because then it's telescoping. Both of these 10.3. Now, another big one. Do I have factorials? then it's ratio. What else? Do I have an everything raised to the n? Because in that case, a root. This is very structured. It's not luck. It's not guessing, right? You sit down and you study what these things look like, right? Another question. Can I integrate? Obviously, integral test. And then I put these 3 dots and I say comparison tests are the last resort. We use limit comparison test 95% of the time. Obviously that is just exaggerating 95% of the time. It's actually 96.1, but whatever. So, and the lecture is over. This is it. There is nothing else to talk about in terms of theory. I don't have any new tests. Now, being that, right, you are noobs now over here, you are, this is all new and scary. It will remain scary until you sit down and memorize the tests. Until you sit down and memorize what the problems look like, the shape of the problem. Because once you memorize what that problem visually it looks like, what the shape it is, then you can ask all of these questions, and there is generally one correct answer to give to that test. So all of the problems are going to look incredibly frustrating and complicated and terrible until you realize that you just need to memorize these things real quick, and you will be instantly able to spot it. Now, coming up, this exam 3 is especially scary for you because it's going to be online test. You might be tempted to say, oh yeah, I'm just going to have a reference and then I'll look at the reference and I will be able to, and it's not going to go well. This is completely new type of mathematics for you. You have never dealt with the discrete mathematics. Everything was x's and linear and functions and so on. All of that now goes through the window. We are dealing with discrete mathematics and limits. So chances of you figuring out a similar example, figuring out that are very slim in the time frame that you have for the test. So knowing the tests, especially that you will need at least a ratio test later on, a root test as well later on, is a must. So we are going to take a look at the problems and see how I determine the test, because I know all of them. And it's going to look easy, right? But again, I am in my natural habitat and you are trying to figure these things out, right? So the way you are going to do this, if you want to do it properly, is you first memorize the tests, then you memorize what the problems look like per each test, and then you try exercises and homework, and then you go into this section 10.8 and you start sorting things, which, and this, as I said before, this section is equivalent to those sections where you go and you say, what is the appropriate integration technique, what is appropriate differentiation technique, right? So this is what is going on. Now, I just took the photo of the tests, and I will be uploading this into Canvas. This is the best chart that it's out there. So give me 1 second here to upload this. Those of you that are online now and you guys are able to do this, let me just jump into this. This is the Spring 2020 files. Let me see. So, oh, come on. There we go. Disgusting, but such is life, right? In this semester. So where are we? Calculus2, Spring 2020. At least maybe I can change. Yep, it's there. Now, can I change the rename? Yes. Okay. Okay, series tests. There we go. Series tests chart, I guess. Chart? Whatever. And when you open this thing, you will find the chart that you can download. And let's see. How bad is this thing? Oh, actually, it's pretty good. It's actually pretty good. You have to open it okay, perfect. Caught a little bit of my knee, a little bit of the floor. Yeah, it's just whatever. All right. Now you have this chart, and I like this chart because way better than what you have in a textbook. You have one of these in your textbook, and it's missing telescoping, right? And it's not in the what I would call a proper order. The reason why I like this particular chart is, look, the nth term test, well, that's your divergence test, is first, telling you, use that, right? And then you see that the two tests that are comparison tests are all the way on the bottom, signifying last resort. Now, other cool things about this chart is, well, they obviously list all 10. You have what the series looks like, you have a condition for convergence, condition for divergence, and then in the comments you see that only geometric and telescoping series have the actually, now that I think of it, why don't we just import all of this mess in here? If I can get Canvas. Oh, come on. Now I gotta log in, and I thought that this was already logged in. Hold on. So we can talk. Perfect. Let's go to courses. Let's go down to Calculus for Spring. Let's go to files. Let's go to the file series. chart. There we go. Let's download this thing. Let's open it up. And I hope you can see this now on the stream. Yes. Now can I do this? Perfect. Okay. So it's in Canvas. Go download this file. It's a picture, right? And when you look at this thing, your divergence is the first. Then you have your geometric telescoping p-series, blah, 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 all the way down, last resort, your direct and limit comparison tests. It shows you exactly the conditions for convergence and divergence. It also, in a comment section, tells you clearly that the only ones you can add and get the sum are telescoping and geometric, which are both learned in 10.3. Now, the question is, can I do the copy over here and maybe paste over here? Oh, hell yeah. Hold on. This is the size. Now, make it larger. And the reason why I want to make it larger in this document here is because I want to fill in this chart. All right, cool. So this over here is your divergence test from 10.4. Geometric telescoping series 10.4. No, 10.3. P series 10.4, integral test 10.4, root and ratio 10.7, alternating 10.6, and these two 10.5. There we go. So those are the sections as they appear in our book, and you will just learn what the problems look like, and when you sort that out, you should be able to. So now I'm going to do the same thing with our problems. This should be good enough. Can add. All of these problems, let me see if the shadows are in here. It's just terrible, but it will work. So I'm going to add more to Canvas so we can discuss these things. So let's go, plus upload. One second, I'll be right there. All right, so now on Canvas I should have two more files. So let's go get those. And I'm just going to write next to them in the book. I mean, these are on these pictures. I'm going to import the same way I did before. So these are this is the second page. This is the first page, right? Yep. All right. So let's place this in. That's going to be good enough. All right. Actually, let me place this. It's one at a time. All right. So let's talk about a couple of these problems here. This is on your book, page 703. So this is page 703, and technically it's one of those choose your test, right? So as you go through these, anytime when you have a mixture of problems, anytime you have a mixture of problems, you can, a mixture of functions, sorry, you would use ratio test. So now 23, right? So 23 has a polynomial on top and has the exponential on the bottom. So in this case, right, you have to choose the ratio test, right? You can see that it's polynomial over exponential, the limit is 0, so divergence test is not going to help. So this is definitely over here, ratio. The next one has the two square roots that you can deal with simply by using integral, right? Now, the next problem gives us this cosine to worry about. It's plus cosine. Now, if you pay attention carefully, when we did comparison test, I said, oh, cosine is bounded by 1. Just get rid of it, right? So this one is going to be comparison to 1 over k cubed, because it is that cosine is bounded by 1 and it really doesn't, you know, or 3 over cosine cubed. You can do limit comparison if you want to. Any one of these that has stuff like this is the comparison, because this part here would be ratio if there wasn't for that plus 1, right? So you can do the comparison to ratio test which doesn't have that plus 1. On the bottom is the ratio to p series. So this is comparison to p series, because you just get, right, j squared k cubed. So that's all basic stuff. Now, you might be tempted over here to say alternating, but I'm just gonna say no, root. And this will die in absolute value. This over here, obviously all root, because you can write the whole thing to the k and then kill that k using the root test. Finally, our ratio, obviously, right? Ratio because of the factorials. Problem 41. You see, there is a minus here, and that's an issue. That minus there is an issue. If this was flipped, it would be a joke of a problem, right? But because it's the minus in denominator, we have to divide everywhere by, let's say, 2 to the k. And then use the comparison test. I'm going to leave you to practice these tests on your own, and then during the office hours or the review, ask specific questions if you have any. This is not a lecture where we learn. We learned all of these tests. Now we are learning to recognize which one is which when they're all on the pile, right? So I am expecting all of you to be able to solve these and then go from there. This should be some form of alternating. This is ratio, right? Why is a ratio? Because it's mixing different functions. That's a polynomial. That's some form of exponential. They're different creatures. Here's the factorial. That's a ratio, right? Cool problem where you have to compress it into summation an and then see what test you get to use. So condensing these, which we learned when we did sequences like a month ago, or 3 weeks ago, whatever, go there and figure things out. And what else? I mean, all of these, they work out to be, comparison. You can quickly see it. This is the same as like 27. Here's your alternating. Another alternating. Oh no, sorry, ratio. There's a factorial there. And ratio will kill this in the absolute value, so we'll have to worry about that. All of the other ones are similar to what we had. Another ratio over here because it has the factorials. And, what's happening with 44? Let's take a look at 44. So, see, this is where I work out algebra in my head. So all of this is going to be k times k minus 9. Can't write. All of this raised to a half. So the limit is 0, so divergence test is out. And now you can do the ratio here. K plus 1, k minus 8, and then do the limit. No. Ratio test is going to come out inconclusive. You're going to get limit is equal to 1. It's not a ratio. Not a ratio test. Well, this one is interesting. Yeah, I'm blanking out now. Oh my, is this a U substitution? This could be a U sub integral test. Try integral test. And then if it doesn't work, we'll figure it out on the stream next time when we do the either office hours or we do the exam review. Which one I did not? Let's go with this one now. Take a look at more of these. So, I'm hoping that you will try at least, 20, 30 of these. Copy. Wow, everything is really laggy. The tablet is overheating, and then when it starts overheating, it starts getting slow. Gets to be painful to do anything on it. Let's pick, some of these. Oops. What do we have? The top one, split, and it's just 2 geometric. That's basic. The limit of this as k goes to infinity is 1 over infinity is 0, cosine of 0 is 1. This is different than this diverges by divergence test immediately, right? For the sign you have to struggle, but for this one it's just dead. Comparison will take this one out, and you will do ratio for the rest. Let's see if we can find interesting stuff. Root obviously will kill the square. We did actually a couple of problems in the class. This might be integral. Comparison again. These are two separate problems. The summation is equal to summation of 1 over k squared plus summation of 1 over k to the 5. They both converge independently, so they will converge together. That's one of those. Here's your root test because you kill that k on top, obviously. Problem 66 is a clear ratio because you have exponents and you have factorials and all of that stuff. I'm going to just say rationalize to get rid of as many of these square roots as you can, and then you go from there. This one obviously diverges just by looking at it because it's e raised to the k, it's positive k. I don't care, you divide by a 10 million, it doesn't matter, right? It's divergent right off the bat. More of our roots over here and more root stuff, comparison stuff. It's just this one you get to rewrite k over 3 to the k squared, kills that minus when you rewrite it, and then it's your ratio test, right? Because you have a polynomial on top and exponential of some kind in the bottom. Same goes here when you rewrite, right? Ooh, finally! I gotta use different color, green. Right? Partial fraction into telescoping, another root, and so on. So just, try as many of these as you can, work them all out, and then you have the list of tests. And again, in my head, I always go, let me do divergence first, and then if the limit is 0, that means divergence doesn't work. It still can diverge by some other test, it's just the divergence didn't detect it. So now it's the time to pick another test. And then I know what they look like in terms of the problems. And then I go and eliminate, right? I ask myself those questions that I had on top, right? Do I have geometric? Do I have alternating? Can I integrate? Right? So all of these different questions, they should all have their own boxes, because they're all different questions that you get to ask yourselves as you are solving these problems. And maybe I forgot some of them, right? The job is to know, right, what to ask, and to know what these things look like, and then you go from there. Let's go this one with the orange, because divergence that we should start with is red. And then finally reaching the comparison tests are the last resort, because you tried everything else, and now you have those pesky +1, -4, and things like that. So the problem is almost one of these main methods. It's almost that, and then it's not, right? Because you have that +1 or whatever. So you can do the comparison to that problem, and then they both converge, both diverge. We need maybe to do the limit, or we need to do comparison of the A less than B or A larger than B, depending on what we have. So that's it. That's what we have for our section, and chapter 10 is over. On Thursday, we are going to, chapter 11, when I teach chapter 11, I teach chapter 11 in 2 lectures. It used to be 1 lecture, the whole chapter, then it's split into 2 sections, and now it's split into 4 sections in 1 chapter. So when we reach chapter 11, the way I teach it is, and I take out some of the fluff out of it because we don't need that. So for chapter 11, I will teach 11.1 and 11.3, and that's going to be this Thursday. And then sometimes next week, depending on what you deal with your exam, it will be 11.2 plus 11.4, right? So I'll call this lecture 1 and then lecture 2. We might start quizzes maybe Thursday or so. We have to have exam 3 next week on chapters 10 and 11, so that we can have our final exam. Final exam has to be on 11 and 12. Semester ends on the 12th. They did not extend the semester because we lost a week. So, it's a little bit crammed at the end. I will be posting announcement regarding that cumulative assignment, like a survey for Calc2 course that is going to be on my MATLAB, where you have to solve all of the problems as a course survey and the final exam prep. final exam review and all of that stuff. That is going to be 10% of your grade. There will be no project, unfortunately, because you guys can't go out to measure things and get stuff that you need. So it's terrible, but it is, it is what it is. So just, watch for the announcements. I will post everything in there. There will be obviously comments underneath. You can voice your disapproval and disappointments in there. And we literally have 2 weeks left, guys. That's it. Today's 28th and we are ending on 12th, so that's literally 14 days. We will be done on that Tuesday is when the last day you can take the final, and probably I'll keep it open till midnight. Minute before midnight. Hopefully posting your grades Wednesday and Thursday, so you can pick whether you want to do pass, no credit, or you want to keep your letter grade. That's it for tonight. I will see you on Thursday at 6, and Thursday might be, definitely 11, 1, and 3. We might also do an exam review on Thursday. We'll see. Bye.